In this session, we are going to talk about a different test, which we call integral test. So far, we have seen two techniques we use for the convergence of the series. The first one was the sequence of partial sum. We said that it is so hard to use, also it is best. And another test for the divergence. Let's look at the integral test. Let's look at an example to set up the integral test. If I consider the convergence of this test, I can benefit using this graph. If you remember, right, how we represented the sequences, we use the graph, as in this case, represent this sequence, the n terms, in this way. N is equal 1, n is equal 2, right? N is equal 3. So that would be something like that. For n is equal 1, I should have 1. For n is equal 2, I'm going to have 1 over 2, and so on and so forth, right? 1 over 3. And the general term actually will be right equal to the, look at that, these rectangle areas. Since the area of this rectangle is going to be 1 times just 1, 1 over 2 times 1, 1 over 3 times 1. If I have the rectangles, right, to represent the general term, I may benefit a function area under curve. So look at this function. What function is that? I can choose y is equal to 1 over x. Can I turn this question into a finding area question? Let me try. The area under y is equal to 1 over x, right, can be represented by this integral. Did you see that? So instead of asking the convergence of the series question, I can ask this question: is this convergent? What's the relation? If I can say that, right, this area under the curve, right, under this function is convergent, look at that, since the area for the rectangles, right, for all rectangles is going to be less than the area of under curve. That's why, right, the series is going to be convergent, since it is less than something which is convergent. Otherwise, if it is divergent, I can find, okay, I can use another area for my rectangles. Look at that. I can do the same thing for these rectangles, guys. Look at it. This time I would take the rectangles above the curve, right? Since they are gonna be the rectangles. And if my function converges, right, for this integral, the area for the rectangles is bigger than the area under curve. That's going to be divergent. So if I summarize this result in this way, if f of x dx from 1 to the infinite, right, is convergent, then my series is convergent. This is the first part of my test. The second part is going to be this one. If f of x dx is divergent, then my series is gonna be divergent. So what's the relation between the function and my end term, right? As you saw from the graph, the function should be equal to my general term at the points for all n, right? For all n, the end term and then function should be equal. There are some other rules actually on f function. F should be a positive function. F should be continuous function. And then third, f should be the decreasing function. So if f doesn't satisfy one of these, okay, you cannot use this test. You should satisfy these features for function f. But since we do online classes, I'm not gonna try to satisfy these features, since explaining all these, okay, is gonna take a lot of time, and I just wanna skip, okay, when you use this test, I'm gonna give always the examples which it does satisfy these conditions. I just want you to apply, if you need to apply the integral test, I just want you to apply the integral without including these features. So let's look at some examples. The first example is this one, which I just showed you, right? So I'm asking if it is convergent. Before the integral test, I may look at some other tests, right, we have learned. I'm not gonna get into the sequence of partial sum, but I can check it out the end term test before the integral test. What was the end term test? It was about end term of my series, which is 1 over n in this case. If you take the limit of this one, which is 0, that's why the test is inconclusive. I decided to use the integral test. To do that, I need to choose a function. Of course, I can choose the same function, which is equal to the right my end term at all those points. The obvious selection is going to be 1 over x. What I should do, integral test says, just apply the integral, right, to this function, this integral, and then look at it if it is convergent or divergent. What is the integral of this one? As you see, it is an improper integral. You should be using this definition. Sorry, b, 1 over x dx. So, ln x, 1 to the b. If you put the bounds, so when b goes infinite, ln b goes infinite, ln 1 is 0, but as you see, my integral is divergent. So if my integral is divergent, from the integral test, what am I going to say? Since this integral, right, is divergent, then my series is also divergent. By the way, this is the special series we call harmonic series. Since it is so important for the other tests, we are going to see later. Harmonic series is the divergent series. Another example, one over n squared. If you use the n-term test, as you see, again, it is inconclusive. That's why I want to use the integral test. And I'm going to choose my function in this fx is equal 1 over x squared. So let's use the integral test. So I need to take this integral, as you know. To take this integral, right, you can just go ahead and then take the integral in a normal way. Or if you remember the p-test, right, what was the p-test? P-test was something like that. If p is equal to bigger than 1, for the improper right integral, you can just say this integral is equal 1 over p minus 1, which is this one. So this integral is going to be equal 1. What does that mean? Since I got a number here, that's why this integral is going to be convergent. Since this integral is convergent, right? Convergent, then I can say that my series is also convergent. But that doesn't mean my series sum is equal 1. Is it bigger than 1 or less than 1? Please think about it. Another example. So if I use the n-term test, the limit of the n-term would be 0, so you cannot say anything about the convergence. But if I use the integral test, I should take the integral of this function so integral is going to be 1 to the b 1 over x squared plus 1 dx. If I take the integral of this one, as you know, it is going to be arctangent x 1 to the b. So when the b goes infinite, the limit of this term is going to be equal arctangent b when b goes infinite is going to be equal pi over 2 minus pi over 4, right? So that's going to be equal pi over 4. As you see, my integral is going to be convergent, right? That is why the series is also convergent.